Hello students, I'm back in the lab. I'm wearing my second favorite shirt and I'm here to talk to you today a little bit about organic reactions and organic synthesis. As you know, in this second half of this unit, we're going to move more into looking at organic synthesis, which is building big complicated molecules from smaller, simpler ones. In order to do that effectively, you need to remember both the reactions we've learned recently and also the ones that maybe we haven't talked a lot about since last October, November, and December. And I know that that's going to take a little bit of searching your memory. I would really encourage you to find this handout. This is your giant table of organic mechanisms. You may have a hard copy of this. If you don't, go to the PowerSchool, and if at all possible, print out a hard copy for you to look at and use while you're going through there, because it will be really helpful to use this as a reference. So, another way that we can sort of get these back in our memory is just by doing some practice exercises. So I have on the board behind me some different types of reactions, some that we've done recently, some that we haven't done for a while. What I'd like for you to do is, in just a moment, press pause on the video, try to write out the answers for as many of these as you can. Don't be afraid, especially at first, to use your free gift. Okay, this is how you're going to get that back in your memory. I'm not expecting that you have all these memorized right now. So use your free gift, see if you can't look up the ones that you're not so sure about, and try them out. So take a minute, I'll move out of the way, pause the video, and then we'll go over them in a few minutes. All right, hopefully you've paused the video and you've had a chance to try these out. So let's go over them real quick. For the first one, this is our good buddy alkene oxidation. We know it's alkene oxidation because we're starting with an alkene and also a powerful oxidizing agent, potassium permanganate. This is the cold base flavor. So we know we're just making that diol, that vicinal diol. You do not need wedges and dashes for the alcohol groups because it's not a ring. And those that molecule can twist around, and so you'll get several different configurations. For this next one, did you get tripped up on this one? This one is going to be super similar to this one, except this is MEA. This is that reaction we learned way back like in October, okay? With water and an alkene, you're only going to make the monool product. You're only going to put in one alcohol group. And where does it go? It obeys Markovnikov's rule, right? Markovnikov's rule says the more electronegative element is going to be bonded to the more substituted position. We also added a hydrogen, right? The other hydrogen from the water, H2O, but we typically don't show that when it's implied. For the next one, another MEA type reaction. Again, we're going to follow Markovnikov's rule, so it looks like that. How about this one? This one is actually two different reactions in once. Again, not explicit, but implied is we have an excess of whatever reagent this is. So this, if you add base, here we have a primary haloalkane. We know in that case we're going to get some substitution. Here we have a tertiary one. In that case, we're going to get some elimination. So here's my substitution. And in this case, we're going to get elimination. And the elimination is going to follow Zaitsev's rule. Right? So here I'm showing the more substituted double bond forming. So this is some elimination, E2. Some SN2, both of these are MEA. This one's our good old buddy, alkene oxidation. How about this one down here at the bottom? This is a redox reaction. Sodium borohydride is a reducing agent. Is it the strong one or the gentle one? It is in fact the gentle one. The gentle one only affects ketones, right, in this case, or aldehydes, which we don't have. This is a carboxylic acid, so it can't touch that one. So the acid group remains unchanged, and the ketone gets reduced to an alcohol, right? So this is some reduction. Over here, what's this reaction over here? Yes, if you said, oh, I forgot the other thing I need to make this work, right? So actually this doesn't really do anything. Silly degrees. What if I added potassium? Now what will this be? Go ahead and pause the video if you didn't know what this one was and try to get an answer for that one. All right, we're back. This tells you we're talking about ether synthesis, Williamson ether synthesis. This makes the alkoxide ion, as you'll recall. So here you're gonna make that ether. This one, this is an acid and an alcohol, is gonna make the ester synthesis. Like that, right? This is the acid part. This is the alcohol part from over here. Voila, you count your carbons. You have 3 here and 2 here, and then 5 here. 1, 2, 3, 4, 5. Bam. This one must be Grignard. Right, so this is going to make the Grignard reagent, NGCl Waga. And that's going to react with that, and we're going to make, let's see, something like this. And then if we add H2O, H2O is going to put an H plus on that, and we're going to make it into that. Cha-ching. And last but not least, a little bit of electrophilic aromatic substitution to make some isopropyl benzene. Okay, how did you feel? If you felt pretty good about it, pat yourselves on the back. This is a lot of different reactions. If you're like, I struggled with that a little bit, we'll do some more practice, okay?